Hello everyone, I'm Sian Proctor. I am the Science Communication Outreach Officer on the JOIDES Resolution Expedition 383, and I'm here with micropaleontologist Oliver Esper. Oliver, you look at diatoms, and what can they tell us about the past climate?
Diatoms are unicellular algae which live in most aquatic environments and therefore also in the Southern Ocean. And they build skeletons out of biogenic opal, which is good recoverable in the sediment. It makes up high amounts of biogenic opal. So whenever we recover cores here, we find a lot of diatoms in. And these diatoms reflect the conditions during the time they lived in the water column.
And so you've got different pictures here of diatoms, and do they all live in the water column at the same time?
No. The diatoms are highly restricted to specific environments. They are dependent on water temperature, nutrient supply, salinity, and even sea ice presence or absence.
So which of these like to live with sea ice and which of them don't?
So the small guy in the lower corner, this is Fragilariopsis curta. This is a so-called sea ice diatom, and it can even live in the small brine channels of sea ice, survive during winter, and when the spring is coming, the ice is melting, curta falls into the water column, which is stratified by the meltwater, and stays there, gets sunlight, and immediately starts to reproduce.
So if you get a sediment and you have, say, 50% of this and 25% of this and, 10% of this in that sediment that you retrieve, what does that tell you?
It would immediately characterize the place where it is produced. So with 50% Antarctica, I would know that it's close to the Antarctic continent. With 25% curta, I know the sea ice is close. And with only 10% of Kerguelensis, which is an open ocean species, I would say we are either in an embayment or close to the coast of Antarctica with temperatures around 0 degrees Celsius.
So when we drill into the sediments and we retrieve this core sample, and then as you go back through that and you take little samples along the way, you find different percentages of these?
If the environmental changed during the time of deposition of the sediment, I would immediately see it by changing percentages. So if we have more sea ice influence, the curta numbers increase.
That's this one?
Yeah, if we have less sea ice and the open ocean conditions prevail, and we've got more Kerguelensis in.
And that's that one?
Yes.
Okay.
So with the exact determination of the assemblage composition, we can say a lot of environmental change.
Great, thank you. Thank you for explaining that to me.
You're welcome.